Hi, I'm Steve Wireman, and today I wanted to talk about multi-threading. Now, multi-threading is the way we tell a computer to do multiple lightweight processes at once. Those lightweight processes are, of course, called threads. Multi-threading is a very important concept in modern computing because most modern machines, even cell phones and all sorts of personal computing devices, are multiprocessor machines, and we want to take full advantage of having multiple processors available to us, and the way we can do that is by writing programs that actually utilize threading. So as a very brief example, I wanted to introduce this with a simple Java thread example. So as we've seen before, I've got my NetBeans project here. I'm just calling this thread example. And I have a few classes in this project. So the first one is just thread example. That's our main project. It has our main method. And you'll see here I have a couple of runnables. Runnable is an interface. I'll talk about that in just a minute. Runnable fib is new Fibonacci. So Fibonacci is a class that I wrote that utilizes the runnable interface. And we have runnable pry is new prime. And you see I'm passing the numbers 100 to both of those. And then we've got two instances of thread, T1 and T2. And to those constructors, I'm sending pry and fib, the instances of runnable that I created. And then I just do t1.start and t2.start. So let's take a look at prime and Fibonacci. So prime, as I said, is a class that implements runnable. Runnable, as I said, is an interface. Interfaces provide the structure of a class. They tell you what methods need to be there. So in the case of runnable, we are required to have one method, and that is this public void run. Anything that implements runnable has to have that method. What that method does depends on what you want your thread to do. So in this case, I want prime to print out prime numbers up to and including max. So what I have here is a run method. It's going to initialize a counter variable I at 2. And so long as I is less than or equal to max, it's going to check to see if I is prime. If it is prime, it's going to print out a P and then the number. What's with the P? I'll get to that in just a second. And then it's going to increment I. So what this will do is it'll print out the numbers 1 or 2 up to whatever max is, if max is prime, provided those numbers are prime. So there is prime method, which is right here. That will just check, is the number 2? Yes, 2 is prime. If the number is not 2, is it a multiple of 2? Well, if it's a multiple of 2, then it's composite. And for everything after that, we're just going to check the odd numbers. This isn't the most efficient way for checking for primes, but it's good enough for our purposes. So we'll check to see if n is divisible by I. If it is, then we return false. If we haven't if we haven't exited our method by this point, then the number is prime and we return true. Let's look at Fibonacci. Fibonacci is going to be a little bit different, not by much. What this is going to do is it's going to print out all the Fibonacci numbers less than or equal to max. So we're going to have 3 variables, x, y, and temp, and we're going to print out, just starting with 0, print out 0. Then we're going to print out y so long as y is less than or equal to max. The Fibonacci sequence, for those of you who don't know, is just the sequence generated by the sum of the two previous numbers. It starts with 0 and 1, and then everything after that is found by adding up those two previous numbers. So you have 0, 1, then 1, and then 2, 3, 5, 8, 13, and so on. So why do I have these printing out two series of numbers? Well, then we can see that both of these things are in fact running at the same time, and they're going to be returning results at the same time. Now, I already ran it. Let me just run it again. So you see, prints out Fibonacci numbers and prime numbers, and the prime numbers are prefaced with P, and the Fibonacci numbers are prefaced with F. So you can see here that both those methods were running at the same time. If this was not a thread, if it was just running these two methods, what would happen, I'll just comment these out, is that it would run in order. So if I did something like fib.run and then pry.run, that's going to print out all the Fibonacci numbers and then all the prime numbers. So you can see those are definitely not running at the same time. If they were, then the results would be mixed up like they were in the previous example. So I hope you found this useful. I will talk more about threads in a later video.